development in our most ambitious project to date, the Apollo moon flight, is well underway. The guidance and navigation station aboard the Apollo is equipped with a scanning telescope, a sextant, a digital computer, and an inertial measurement unit. Attitude and guidance controls can be operated directly by the navigator or automatically by the computer at the direction of the navigator. This complete system permits all navigation for the lunar journey to be performed on board, independent of Earth-based tracking or computing facilities if necessary. The navigator will make repeated sightings to confirm his position and trajectory. However, throughout the entire lunar trip, he will have Earth-based tracking information available for use in his own computer. This is how the onboard equipment works. The line of sight of the scanning telescope is fixed to the spacecraft. Looking through this scope, the navigator acquires the Earth and a selected star. He maneuvers the spacecraft until the Earth landmark is centered at 0. Rotation of the telescope reticle till it falls across the star also turns the sextant. He notes the angle of the star and sets the sextant at that angle. Now, looking through the sextant, both images will appear enlarged and superimposed. When they are lined up, he pushes the Mark button. This feeds the precise time and angle information into the computer. The computer also receives Earth-based tracking data, which when combined with the observed data, keeps the navigator informed of his current position and actual trajectory. The navigator instructs the computer to make the necessary trajectory correction. It determines the exact amount and direction of thrust needed to accomplish this correction. The inertial measurement unit furnishes a sense of direction to the computer, enabling the spacecraft to be correctly oriented. The rocket is fired. The inertial measurement unit measures the acceleration, feeding this data to the computer. When the desired speed change is accomplished, the computer cuts off the engine, and now the spacecraft is on its corrected course. More than one correction may be needed. As the moon is approached, sextant readings will be made between known lunar landmarks and appropriate stars to determine the final course correction. Both onboard and Earth-based computers determine independently what maneuver is required to place the Apollo craft into a lunar orbit. The familiar landmark tracking technique is then used to confirm the parking orbit, putting man for the first time in a position to land on extraterrestrial ground. The navigational experience gained in the Apollo program will contribute information needed for trips of greater complexity. For man is not content unless he's pressing himself to the limits of his knowledge or beyond.